I'm Kyle.
I'm Raina.
I'm David.
And we have been working in the cosmic frontier, more specifically dark matter.
Dark matter is a large part of our universe. Most scientists think that it makes up about 95% of our universe, so that leaves only about 5% about what we do know, which is our basic standard model. And here is a visual, which I'm sure you've all seen this upstairs. And the black jelly beans represent dark matter and dark energy, and the colored jelly beans represent what we do know about matter. And scientists know that dark matter exists because it has gravitational forces on everything else around it. And from astrophysical observations that we've taken from other galaxies and everything out in space shows that if everything in these galaxies were to be made of regular matter, then everything would fly apart. And so scientists think that there has to be something else to be keeping everything together. And basically, our universe has three basic fates. Everything is, if it were an open universe, everything would continue to expand until it rips. If it were a closed universe, everything would continue to expand until there was a big crunch.
Happy thoughts.
Yeah. And it would shrink back to the size of where we started in the Big Bang. And if it were a flat universe, everything would expand until we reach equilibrium. And scientists think that if there's as much dark matter and dark energy as they say in the universe, that this could predict the fate of our universe. And even though this is tens of billions of years into the future, personally, I think it'd be really cool to know how we're going to end up. And scientists think that being able to study dark matter is going to open up a lot of opportunities, even though it's not easy to study. First of all, it's invisible, and it doesn't contain a lot of mass, and so that's why at first neutrinos were a good candidate for what dark matter and dark energy were going to be made of. And if we were to be able to study this, well, because we don't really know what it is yet, basically know what it's not, and they might open up the possibility of a fifth force, which obviously would change our whole standard model because certain forces interact with certain particles. And also it could open up the theory of supersymmetric particles, which are particles that are heavier and already match up with particles on our standard model. So I don't even know how that would begin to change our whole conception of particle physics. And so here's David.
Fermilab and NASA are working together with the Fermilab Theoretical Astrophysics Group, which is partially funded by NASA. And this collaboration and many others like it are remarkable because scientists from all over the world can come together just simply to learn about the universe. I want this group to continue working at Fermilab because I'm considering becoming an astronomer, and the information would get to me a lot quicker, and it would be very useful if I do become an astronomer.
There have been 3 recent dark matter and dark energy experiments at Fermilab. One of the most recently that's had results is cryogenic dark matter search, or CDMS. It is basically this box where they freeze it down to almost absolute zero, where the particles almost stop moving. And every now and then, since as Raina says, dark matter has very little mass, it can pass through objects like empty space. And eventually, and sometimes they'll collide with the particles in the box, and they have a detector which can read these collisions. So far, we only have 2 collisions, but if we get 5, then we can actually claim discovery for the actually existence of dark matter, since it's still just a theory. There's also Dark Energy Survey, or DES. Fermilab and a bunch of other organizations are working together to build this big dark energy camera, which has some readers and telescopes, which when they send it out, they'll actually learn a bit more about dark energy. And finally, COOP, Chicagoland Observatory for Underground Particle Physics. It is located in the NUMMI tunnel that Nathan and Brandon mentioned earlier. It's basically this big temperature-controlled bubble chamber, where when particles pass through the empty space in this bubble chamber, it makes these patterns of bubbles, and each particle makes different bubble patterns and sizes, so they can tell which type of particle passes through. So they can tell if a dark matter particle passes through, or if something else.
These experiments that Kyle talked about are vital because they could solve many of the mysteries of our universe. And since about 95% of our universe is believed to be dark matter and dark energy, it could solve many more mysteries than we could ever think of. And since CERN isn't working with dark matter and dark energy, Fermilab needs to keep doing these experiments. Without them, many questions would be left unanswered. If information about dark matter and dark energy were found at Fermilab, Fermilab could become a lot more prestigious, and Batavia would become a lot more popular as well.
How this relates to me is that I, for one, just think dark matter is really cool. And also, like David said, I also was thinking of doing something in the field of astronomy. Plus, I also think that the cosmic frontier sometimes gets a bit neglected sometimes. Because here at Fermilab, the main focus was the energy frontier, but with the shutting down of the Tevatron, it's going to focus to the intensity. But the cosmic frontier is still out. So I feel like that just needs a bit more importance for some people to realize.
And this relates to me because my mom works at Fermi Lab. My mom. And she really loves her job. She likes educating people about science and educating children. And I'm not really sure how that would impact her if Fermi Lab were to shut down or the Tevatron were to shut down. And so I'd hate to see if she got laid off or her hours were to lessen because she really likes her job. And also recently, I went to Fermi Lab on Fridays on a field trip, and I found out that CERN usually only collides protons on protons. And Fermi Lab is one of the only place in the world that makes antiprotons on a large scale, enough for collisions. And so since Fermi Lab is such a unique place, I'd hate to see it shut down.
Well, that concludes our presentation. We may not have won much in the space race, but Fermilab is leading the cosmic frontier. Next up is Dan and Donovan with future projects.